1, go 3, 2, 1. Just forward and left.
All right. Thanks for watching Science with Mike. Lit crowd here, right? Lit crowd. These guys, they don't require. I thought I'd have to warm them up. It's just they're all crazy. We'll probably get out of here okay. Anyhow, thanks for watching Science with Mike. I'm Mike, and I've been teaching here at Sinclair for 23 years. One of my philosophies is that science is not really scary if you show people examples of it and how it touches your everyday life. Cable dropped over there, it's okay, and we're good. So anyhow, thanks again for watching Science with Mike. Today we're going to talk about some gases, all right? And I'm going to need the help of my people here, and we're going to need the help of you people watching. So I have two lovely assistants, Kimberly and Addie, who are watching. That's it, yeah, give it up for them. And so they're going to be watching some of the stuff that's going on out there in the internet world, and we'll answer comments and questions that way. Okay, first I want to talk about air, all right? Anybody, what's an air? What's in air?
Everything around us.
Oh, okay, but what are the compounds, or what are the molecules that are in the air?
Oxygen.
Nitrogen. Yep. Nitrogen. Oxygen. Yes, sir?
Argon.
Argon is number 3. We got all the big 3 right there, okay? When you came in here, you pushed out, on average, 60 liters of air, all right? You big bullies. Pushing it around wherever you go. Does it weigh anything?
Yes.
Yeah. Weighs about 2.5 ounces. If you're 60 liters, you're not 60 liters yet, buddy. You're about 28 liters. He'll get there. You're going to be 60 liters someday. Okay. Anyhow, so what we're going to talk about is the weight of things relative to air. So let me show you what I've got prepared for you here. Dang. That was not supposed to happen. But anyhow, what we've got going on. These are the two main components of air, and we like to talk about their mass based on what their mass is in the periodic table. That's the big number below the element, that's the atomic mass. Nitrogen, 28, oxygen, 32. Seeing as it's about 3/4 nitrogen, it's about 29 AMUs. All right? Now, what's coming out of here? That's natural gas. All right? And it's mostly methane. And so, that's where's natural gas come from? Anybody?
The ground, the earth.
The ground, cows.
Okay.
Methane. Cows too. That's methane. Okay, let me ask you this: lighter or heavier than air? Methane.
Lighter.
Lighter. That's for sure. So what we're going to do is we're going to show you that. I'm donning my safety glasses now, even though this is not. It's the first applause break for safety glasses. Applause break for safety glasses. I never thought.
That's why your hair's so short right here?
That's it's. All right. So what we're doing?
Ether and a lighter?
Yes. No, we're not. Okay. Nonetheless, kind of making me nervous. Okay.
I brought ether.
I'm sure you did. All right, and a rag. Okay. So. What we're going to do here, this is what we call in science a candle on the end of a stick. And so...
It's not a jalapeno on a stick?
No. God, oh, please no. Not a prop comic. Okay, so what we're going to do is make some bubbles, and we're going to show you that those bubbles, in theory, should rise. And we need to turn up my gas volume here, because it's taken too long. That's what we call, in science, taking too long. And so there we go. All right. And then if I'm lucky, I'll break it off and we'll light it. Because yeah. I know, you feel it a little bit, don't you? Okay, so let's do that again. Because I know, I love it, trust me.
What's inside that bubble?
That is methane. Sorry, it's mostly methane. It's natural gas. It's got some, ethane and a little tiny bit of propane, but on average, okay, now we can only do that like 14 more times. That one was.
Can I be Gene Simmons and do it out of my mouth?
At home you could. No, don't do any of this at home. I'm sorry.
Fairfield Fire Department called Mark Martin burnt the house down today.
Okay, so I don't want to burn the building down, I promise.
I've got a fire extinguisher on me, and if you... Uh-oh, can you
Okay, one more, and then we're going to switch subjects here. So then we'll turn to our...
Kind of smells like burnt hair. That's mine.
That's actually my hair. All right, very good. Let's quit while we're ahead with that one. What do you
Silly material.
So, yeah. All right, cool. So, all right, this is where we now we're going to turn to the internet. Did anybody say anything about that or nothing?
I should go to your college, and I love this show.
Okay, says who?
Sinclair says, and not Sinclair is in here, but Sinclair is in this person, says, I should go to your college. And then Lynn O'Brien says, love this show.
Okay, Lynn O'Brien, thank you very much. And that was a little bit with methane. So there we go. Next, we're going to switch gases.
Stay behind the count, get the same result.
Next, yeah. Oh, sorry, I got to read. Anyhow, so nonetheless, okay. What else do we got? Do we got any other questions? We got more coming, so it's okay if not. Okay, that's fine. Any questions from here before we move to something else? Okay, that's fine. I'm used.
Oxyacetylene.
Okay. Okay. So cool. We're going to deal with the tank next. Okay, what's in the tank? Anybody want to guess? It's the lightest molecule there is. Lightest molecule. Now, helium's an atom. Hydrogen. Okay? Really, really light. Okay, come on in. That's okay. All right, that's cool. So hydrogen, H2, 2 AMUs. So not only does it rise even more than methane, but it is also flammable. And I'm going to try to show you that with this here candle. All right, and I'm going to put it what hopefully is a safe distance and shut my gas off. This is a tank of hydrogen, and what I'm going to do is I'm going to make some bubbles, but actually I'm going to try to capture them by putting soap solution in there. All right. Kind of sounds like Willy Wonka's car. All right.
Wilder version.
Okay, and then, realize I've practiced this a gazillion times, so this is not the kind of thing you want to try at home, but I'm going to take my hand, and I'm going to scoop up some of the bubbles. I'm going to take this, and then, there you go. You missed it? I'm doing it again.
Yes.
It doesn't really hurt. It doesn't really hurt. Huh? No, I don't. Afterwards, in quiet. Okay, go. Yeah, okay, that's it. Okay, good. I know. Yeah. It happens when you invite public. Okay, so. All right. Not really that much heat, right?
Is that really? No, it's
Did he
not
say
really
release?
hot.
Huh?
That doesn't get really hot.
Not really. There's not
No,
enough mass.
It's instant.
Not enough mass really to get it hot. Okay.
It's not like lighter fluid or anything.
Next, I'm going to show you how the combustion, as I switch these hoses, maybe that'd be a good time to check in with our people.
Lynn O'Brien asked, did it hurt?
Lynn O'Brien asked, did it hurt? No, Lynn just feels a little bit warm. And I kind of was trying to explain, there's not really enough mass with gas. Remember I talked about how 60 liters of your volume pushes out 2.5 ounces. So gases don't really have enough mass if you combust it. You notice that didn't produce enough heat to really burn the ceiling. So when you burn gases, they're not really all that massive, so not as much heat. So, all right.
And then Colin Harris said she's a little late, so she didn't get to catch what gases were involved in your last experiment.
Methane was the previous one. By the time I connect this hose, we'll be able to, I'll be able to talk all over about it. And now we're going to switch to, we're switching to hydrogen, and I'm going to fill up a test tube with hydrogen. So here we are going with hydrogen, and I'm going to now just show you a little bit of what the reaction is between hydrogen and oxygen. Bless you. All right. So when you take hydrogen and it reacts in the air, you're just making water. All right. I'll try to show you here by filling up this test tube. By the way, you can kind of if you listen real hard, you can tell the frequency of it gets a lot higher. And then when it kind of taps out, it tops out in frequency. That's when you know that it's full. And anybody see that? That's water. Okay? That's just condensation of water. All right? And so now I'm going to go ahead and do another one. I got to fill it up with air though, so I just that's stupid. Okay, we'll do one more of these. Then I got a treat for you, and I got to kind of warn you about the next one because it's a little bit scary. Okay, there we go. A little bit more water. Of course, if it was warm enough, that condensation wouldn't happen. It'd stay water vapor. All right. Okay. Who likes loud noises? Okay. Who's scared of loud noises? Especially kids. Okay. There you go. So here's the deal. I'm going to introduce you next to the Sinclair H-bomb. All right. It's a very sophisticated piece of technology, and this is going to be where we're going to end on here. I've just basically taken a nail, and I've punched a little hole in the top, and I've cut out a little bit bigger hole in the bottom. All right. And what's going to happen is the hydrogen's going to naturally rise, and if I light it with a match, it's going to undergo that reaction. Okay, it's going to undergo the reaction to produce water. There'll be a little flame going on here. But the reaction occurs much, much quicker when you get it in the proper ratios. So as much as you don't really want to mess around with hydrogen when it's pure, and I could put it in my hand, and that's great because it's not contained or anything, and that's not a big deal. If you combine hydrogen and oxygen in a 2-to-1 ratio, that's called a stoichiometric ratio. That is a super explosive mixture. So what's going to happen is we're going to go ahead and we're going to place the H-bomb right here, a safe distance away, and I'm going to fill this thing with hydrogen. Okay? Got to put our logo out there for branding. And it's going to take a while, okay? But kids, I don't want you to be scared. When this happens, I want you like this, okay? Because you got the rest of your hearing life in front of you. Grown-ups, whatever. You're probably, their hearing is already shot because of kids. But anyway, so it's going to be a little loud. It's going to take a little while, and you'll actually hear it make a noise as it gets close to that 2-to-1 ratio, okay? And so what I'll do is the first one we'll do just with the lights on, so you can kind of watch what's going on. But I'm warning you, it's a little bit on the loud side. And then let me fill. Remember, listen for the sound. Actually, I might need my lovely assistant to light that candle. The big long one. Okay, ready? Listen for the sound, guys. See, that's probably when it's about full. Okay? Quick, go over here. Okay, brace yourselves, guys. Okay. Okay, hang in there. I'm getting it, guys. Wait a second. Okay, really listen for that sound. It's probably going to be about a minute away. I swear I get the jitters, I shake. Yeah, it did light, I think. There's a chance it blew out, but here goes. There it is. Yeah! Yeah, it's got a little bent out too there. So. I'll tell you what, that lid still fits. What do you say? We got one more. We'll do it in the dark. You'll see, if we are lucky, you'll see the flame get sucked back in, and then the explosion happens. Okay, and so, but it's really pretty safe. What I did is, where'd my little clay triangle go? Okay, that happens. What I what I did is I gave it kind of not a very firm platform to launch off of, so some of that energy gets sucked out. And so that keeps the can from like hitting the ceiling. The ceiling is doomed in this room, I swear to you. So, okay, let's do another one, and then we're going to field questions, and then that's the deal. Okay, so once again. This time I'm going to shut the lights off, okay? Yeah, Kim, get out of here. Save yourselves. Turn that off. Can you see the flame there? Yeah. Okay. This thing kills me. Here we go.
Why does it make that noise?
You know, I don't really know. I don't know what's quite going on there, but it's some sort of frequency of it getting to the... It almost makes me think it's a flame going up to the top. Like I have a thing called a whoosh bottle, and it burns from top to bottom. But it's something about the sucking the air back in there, and I don't really know what it is, and I'm too... Go ahead.
Question, would it be because the gases are lessening and they're speeding up?
Well, you know, the gases in there are becoming more oxygen-rich, so what's happening, if anything, is that can's getting heavier. You know what I'm saying? Because it's now emptying of hydrogen and it's filling with air. So I'm
forcing.
We need a colorless one to look and see what's going on. You can't, you know, there's only flame at the top, so...
Shatterproof glass.
Yeah.
All your thing.
Yeah. Questions from the internet world and then from anybody here at all?
Shakina asks, do they use hydrogen and oxygen or a variation to launch toy rocket ships?
Okay. Well, what was her name again? I forgot.
Shakina.
Shakina. Well, Shakina, do they use hydrogen and oxygen to make toy? No, I don't think so. I'm going to guess no. Because toy, you mean like the water ones or whatever with water pressure? I'm not sure, but that would not be something I'd put with kids. Disclaimer right here, do not do this at home, not suitable for children. I'm a trained professional. Thank you for your question, but nonetheless, another question maybe?
Is that combination used in bombs, like a hydrogen bomb?
No, that's a nuclear reaction, you know. But that would be a bad thing. But it would be hard to contain, right? So the question was, is that what's in a bomb? And usually that's why they use solids because it's contained. But we should probably talk about bombs. Over back to the internet world.
Yes. One from Chris Canistero. How much?
That guy.
How much credit do you owe to your brother Chris for your success?
You had a question.
What? Sorry, Chris.
He knows I'm joking.
What was the ratio in the Hindenburg when it went off?
Well, the thing is, that burned a lot slower, the Hindenburg, and that was like kind of like the bubbles here, all right? And that burned a lot slower because it was pure hydrogen, and the oxygen was coming in from outside. But that was exactly what happened with the Hindenburg, is that people thought it was a good idea to make a blimp out of hydrogen, and so don't do that at home either. Guys, I think we're going to sign off here, but I do want to end this on a very kind of profound note. What I want to do is I want to sign these things off with our young people, and I want you guys to, if you got friends looking at home watching, that's what we need. We need people who go into what we call STEM careers. And so what I have is I have a little prepared sign-off statement. So would any young people want to join me up here, and we could look at the cameras and you could see your buddies? And if not, that's okay. You want to, because here's the deal, guys. You guys, yeah, come on up. You guys are going to be the ones that are going to build our bridges, and you're going to make the medications that we take, and you're going to be doctors and nurses that touch our feet and stuff. So we're going to sign off now. First of all, do you guys agree with that statement that we're going to say together?
Yes.
Okay, do you guys? All right. So what we're going to do is we're all going to say it together. Can you see it? Okay, get in here and then look at the cameras because your buddies, you can show your buddies later that you were here. Okay? So right up there at that camera, and we'll say it on the count of 3. We'll say this and then that, okay? Okay, 1, 2, 3. Thanks for watching Science with Mike. The Earth is not flat. Thanks for watching, you guys. See you in a week. Awesome. Okay, cool. We have T-shirts for you guys. We also have like waivers to sign later.